Okay, so we're talking about exponentials, and this first one should be easy as pie. It starts at what? 5. It has growth, right, of what? Is it exponential growth? Yes, because it's an exponential, because there's an x in the exponent, and there isn't an x as the base. All right, how about this guy? Is it growth or decay? Decay. What percent decay? Yeah, that's a really easy, common mistake. People say 98%, and a lot of you corrected yourself. But what I recommend that you do is that on a problem like this, just to be sure, because, hey, you might even think, oh, this is an R2. I don't care about those. I want the R3s right. But you got to get 3 out of 4 of your R2s right to get a B. Unless you're going to gamble it all on the R3s. And if you get 3 out of 4 of those right, you're fine. But if you don't, which I think could happen, you could get 2 of your R3s right this time. And you'd have a chance at a B. You got to get 3/4 of the easy ones right. So here's a strategy on this easy one. If you rewrite this as 1 plus or 1 minus something, what is 0.002? That's 1 minus what? 0.998. If you didn't know that, you could use a calculator, because we just figured out that it looks like calculators are going to be allowed in the whole test instead of being like half the test. Probably have a calculator for the whole thing. But anyway, if you took 1 minus 0.998, now you got 0.002. Well, which one do I use to tell the percent? That one. That's why we rewrote it. So now it's 99.8% decay. That's going down really, really fast. All right. This one. Is it decay or growth? Decay. Rewrite this, please, as a 1 minus something. And then be very careful, because, again, these aren't that hard, but it'll catch a lot of kids who are going too fast. And they'll say, oh, yeah, it's 3%. Duh. Done. And they'll be wrong. So rewrite this as 1 minus something. One minus what? 0.003. Is that 3%? No, it's not. What is it? 0.3%. See how easy that would be to goof up? All right, moving on. This one. Again, common mistake here is, even if the kid is smart enough to remember, oh yeah, write it as 1 plus something, so that's 1 plus 8, so it's 800% growth. Wrong. Why isn't it growth at all? That negative in the exponent. So what does that mean? I rewrite it as 5 to the, instead of 9, I do the negative thing to it, 1/9, and that's to the x. Now would you please write that as 1 plus or 1 minus something, so you can tell what percent decay it is. It's clearly got to be 1 minus something, right? To make it down to 1/9. Would you agree it'd be 1 minus 8/9? And if you knew 8/9 was 0.88888888, then you'd probably be able to say that it's 5, y equals 5 times 1 minus 0.888, good enough, to the x. And then what's my final answer? What percent decay is it? And then so many people go back to, like, now taking this and turning it into 0.002 or something. No, the reason we wrote this is because that is the answer. And what percent is that? 88%. Growth or decay? Decay. If you look back at this one, you can see that it's a decimal there. So it's not going to grow, it's going to decay. All right, so one more. Is that growth or decay? Decay. What percent decay? 99.8. We did that one before, didn't we? Dang, that's all right. I think you're getting the idea. How about this? So many people are going to go, oh, 12, so that it's 88. 88% decay. Wrong. What would you subtract from that? 98.8. So this one is, why did I just rewrite that? Because that's the answer. 98.8% decay. Okay? All right, next topic. If I tell you the starting value and one other point, then I'm talking about either this kind of graph or the blue kind. You are correct. We must be talking about the green kind in this case because the blue kind needs a limit. I'd have to tell you the limit. Good. So generally that's what it looks like, but you should be able to write y equals a b to the x, stick the numbers in, and I'm just going to walk you through this at the beginning because I've been kind of glossing over something that's kind of important. Y a b to the x, and then I usually just take the starting value and slap it in right here. That's dangerous. Let me explain why. Because the starting value is really this spot, right? That's also known as the what? Y-intercept. The y-intercept is where x is 0, right? So what I should really be doing is putting in x is 0 and y is 4. X is 0 and y is 4. Do you get how in this case that would be 4 equals a times, what's b to the 0? 1, so it's just 4 equals a, so a is 4. Now you might say, well, why didn't you just stick the 4 in there then? Because there are some problems where it's like plus 7 at the end. And then you can't just stick the 4 in here. Do you understand what I mean? So there are exceptions. So, all right, so back to, now we've done it. We figured out a is 4. Now I'm going to put the 4 in there. So I'm going to put the 4 in there. And now I can take my other point, which is here, and plug it in there and there. I'd like you to try that and use your calculator. You need to borrow one if you have to, but get a calculator out in your desk. Give it your best shot. Yes, sir? When we're talking about these, we're going to give you, for logistic, we're going to give you the simpler kind. No, sorry, for this kind, for exponential, we're just going to give you the simple kind. So don't worry about it on this one. I'm more trying to set you up on the logistic ones. I actually did it wrong on Friday. And on the logistic ones, you have to do the thing I just showed you. For right now, back to just stick in 3/4 here, and 3 and 7 there, and solve this puppy. Make sure you've got the basic algebra skills you need to be able to do that. But I do get what you're saying. I'm mainly concerned with the logistic problems, the ones that look like this, because those are the ones that I was using a shortcut that doesn't work. So back to this, 4b to the 3/4. So then I divide by 4, 7 divided by 4, b to the 3/4. Now how do I get the b alone? I put it to the 4/3. And then that cancels, b is alone, that's what I wanted. B to the 1, but it's the same thing as b. So then it tests whether or not you can put in 7/4 to the 4/3 correctly. I'm going to pause while I do that. Okay, did you guys get 2.108? All right, is that the answer? No, the answer is the equation. It's y equals starting value 4, b value 2.108 to the x. That's the answer. Unless the question had said something like, at time 5, how many weevils are in the box, or whatever. Then I'd put in a 5 here and figure out their answer for them. But you'd start by getting this equation. Or they could also say, I want to know when it hit 62. So I'd put a 62 in here and solve for the x. I'd have to graph both sides. Graph this side, graph that side, see where they crossed. Okay, so anyway, this one all I wanted was the equation. So that's it. It's done. By the way, is that 21% growth? No, that's so messed up that it's hard to even know where to start. It's not anywhere close to that, is it? Isn't it like 100 and some percent growth? You could rewrite it as 1 plus 1.108. 1 plus 1.108. Then I'd say that's about 110%, right? 111% maybe. All right. Moving on. This one, I know that it's decay. But do you know how to write the limit for that? Generally, limits start as lim of the function, as x approaches whatever. But if I were you, whenever I was making a limit, I'd have a sketch first. This starts at 5, and then what's it do? Okay, so sketch it on your paper, and then write me the limit for both ends. I'll see if you do it right. Alright, so first of all, does your sketch kind of look like that? Something like that anyway? Because remember, it's decay. Starts at 5, but it doesn't go up. It goes down. Okay, next, I'd say lim of the function as x approaches, and then I put an equals. And notice that's the framework that I use for any problem. So I'm just going to cheat and take that and clone it and drag it over here and say it's the same answer. Now I just have to fill in x goes to what? On the left side, that's way over here, x would be negative infinity. Raise your hand if you had that right for the left side. Okay, then what is it when I get there? It's positive infinity, because this is kind of going up, so it's going to be, when I get way over here, it's going to be way up there, positive infinity. And the other one is x approaches positive infinity. It would approach what? 0. Very good. That's limits. That's one of the easier things. That's more like an R2 level kind of question. Any questions on that? All right. Just to have, if you know what the picture looks like, it should be easy to write the limits for it. So let's get yourself a picture. All right, more advanced application question. Let me ask you this. Did I tell you a limit on this? Then it must be one of the more normal ones. But if I used these numbers the way they are, it wouldn't work. Why? Because the starting value is supposed to be where? At 0. This is supposed to be a 0. And therefore, what's the other one got to be? A 5. And I think we did this one the other day, didn't we? So we did y equals a b to the x. Let's do it fast. What's the starting value? 20,000. So I put it right there, and I'd have y equals 20,000, and I put the x is 5 and the y is 1250, and then I just solve it down, and that's pretty easy, isn't it? How come this problem is different then? When will there be only 1,000 birds? Yes, except there's x and a y. What's x in this problem? Nope, I have failed as a teacher. X is years. See? Years, x. And the other is birds. So what do you think they're giving me, an x or a y? Giving you a y. So let's say I have my equation. I'm just going to take, I would like to have people do different parts of this. Would you please take 1250 divided by 20,000? And that's b to the 5th. Maxwell, you get ready. And you're going to be typing in whatever she says. Go ahead. And now we got to put that to the, so put to the caret, power of 1/5. And what'd you get? And the 1/5 has to be in parentheses. Did you do that? When you put in your 1/5, did you put it in parentheses?
Yeah.
Good. What'd you get?
Wait. Put it in the graph.
Okay, don't want the graph. 0.0625 to the power of 1/5.
This is great.
0.5743. Thank you. That's all right. That's right. I know you were gone a couple days. I didn't mean to pick on you. Just saw you in the front row. And all right. So there's that as B. So now here's your equation. And everybody, I think, could have got to this part themselves, I hope. 0.57. Let's put it right there. times that to the x. But when the teacher or the test says 1,000 birds, you gotta know where to put that now. 1,000 goes here. Now, how the heck are you supposed to solve this when it has an x in the exponent? The only way is logs, or what will solve pretty much any problem, and therefore we sometimes have to take them off the test because they can solve pretty much any problem. Graphic calculators. So use it, since you're going to be allowed to use a calculator. How do you graph this and solve it? You graph this side, you graph this side, y equals, by the way, and you see where they what? Do it. I'll warn you that your window, because y is 1,000, your window needs to go up at least to 1,000, right? Your y's need to go maybe from 0 to 1,500 or something. Need a calculator? I have some. Anybody else want to borrow one? If so, please come now. All right, mine looks like this after I got the two equations in like this. I use 0.57, but 5743 is better. Okay, I'll go down. I'll insert that. So I'll make mine like yours. Ah. Second insert 4-3 enter. Okay, and then if you set your window right, I personally used this window between 1 and 60, although that was probably overkill. I'll go down to like 1 and 30, it'd be plenty. And then my y's I put between 50 and about 1,500. Again, that could be 0 and it wouldn't hurt anything, whatever. Graph. Okay. So you see that they cross, right? And intersect, since these only cross once, intersect is really easy. You go second, calculate. If you don't know how to do this, you need to learn it now. Calculate the intersection points, number 5. And then it asks for the first line, hit enter. Second line, it automatically bounces the spider to the second line. It's actually blinking there if you can see it on the screen. And then it says guess. You're supposed to arrow over until it's like right where they cross, but you know what, since they only cross in one place, it doesn't really matter. I hit enter one more time and it'll tell me 5.4 approximately. Okay, what did I just figure out? There's 5.4 chickens?
Years.
5.4 is the year. Now really, come on, is 5.4 a year? No, then we need to go back and look at what we had in the original. You see how 5.4 is just a little past this? And that was the year 2000 what? So 5.4 would be a little past the year 2015, right? Unless you consider 5.4 being just in the middle of 2015. It's hard to tell. It all depends on how you define it. And I would say that if you get it that far, I would have said 2015 was a good enough answer. I think we'd be trying to trick you if we made it 2016. So, in the middle of the year 2015. Well, it is either one or the other. But then you'd have to ask me, what you would have said is, which assumption should I make? That the year 2010, that this is the very beginning of the year 2010, or the very end? And what most people would assume is that's the very beginning of the year 2015, and therefore, this is the very beginning of 2010, and therefore 5 would be the very beginning of the year 2015, and so the really right answer is 2015. But I don't know if I'd mark it wrong, but 2015.4, do you get that that's not right? It's about 40% into the way of the year, so 2015, so like if you really want to get technical, it'd be 40% of the way into the year, but let's not go there. Now you guys are asking too many questions. This video is going to go forever. All right, moving on. All right, this one. This is the harder kind, and this is the kind that I goofed up on before because I thought I could just use that shortcut. You know where I said, oh, starting value is, just stick it right there. Doesn't work in this case. Remember I showed you in that other kind, there's some kinds where that won't work. This is one of the kinds where it won't work. So let's do this together. Everybody write that general formula down. L over 1 plus AB to the x. And we'll put in some numbers that we do know. All right. One thing we do know is that the maximum population is 200. That goes right there. That is not a problem. It's not complicated. You just put it there. But the A is not so simple anymore. Remember, the starting value, the y-intercept, is 60. That means that this spot right here is at x is 0 and y is 60. Do you get that that's really two numbers? X is 0 and y is 60. Then you should put x is 0 and y is 60 and solve for A. Get what I just did there? I just put it in as a point. Now, you might think, but there's an A and a B. But the B is to the 0 power, which means it's really going to equal 1. So it's really not even there anymore. Get that? So then you just got to solve this. 60 equals 200 over 1 plus A. Okay, my first thought in solving this is to multiply both sides by 1 plus A. Then I'm going to have 60. Oh, wait. At this point, there is a faster way to do this than multiplying that in. I'm trying to get A alone, right? Do you get that I could divide by 60 right now? It would have been okay to multiply it in, but it would have been simpler to do this. So 1 plus A equals, well, what's 200 divided by 60? Somebody? 3.33. Good enough. And then I'm going to subtract 1 from both sides. It took me a while. But you know how I used to stick in A was whatever? Whatever they told me? Doesn't work. Because what is A? 2.33. So I now can put a 2.33 right there. So now I have y equals 200 over 1 plus 2.33 b to the x. And now I take the other point, 2 comma 80, and drop it in there. X is 2, y is 80, and solve that one. Now, word to the wise. If it doesn't say solve algebraically, what would be a really easy way to solve this? Yeah. Let's grab a calculator. Go ahead and try it. See what 2 lines cross. Either that or you can solve it algebraically if you want to. That'll work. This test is called a communications test, which implies that you don't necessarily have to use algebra unless Mr. Van Dyke puts it in there, solve algebraically. If he doesn't put that, you can just use a calculator, graph it. Be faster. Yes, sir.
So if we did solve algebraically, come out with like a fraction, should we do it like that, or should we do that?
If I were you and I was, remember, we're solving for B, I would like a decimal for B. It would be easier because you can, I don't know. You could do a fraction. That'd be all right. But you're probably going to use a calculator. You're probably going to get a decimal if you divide them anyway. So it's, since you're using the calculator, you might as well just divide it. And what did you get? All right. If you haven't done it yet, what I'd recommend, we get like 2 or 3 people to get the same answer, and then we'll trust them. Anybody got it done yet? Sarah, we can. Ah, there could be 2 intersection points. But one of them might be negative, which would imply that it's not allowed. What did you get? Did you find the negative one, I suppose? Okay. What's the other? What's the positive one? What's positive one? Oh, is there two of the same thing? One's positive, one's negative? Ah, okay, well, we're going to take the positive one. Well, anytime you're dealing in the real world, you almost always end up throwing out negative ones. I mean, you can't have negative time. You can't have negative lengths of sides. You know, so usually you got two answers. Throw out the negative one, use the positive one. In this case, they're both the same number, so it works out real easy. All right, so by the way, what was it again? I want to write this out now. 200 over 1 plus A, I figured out right here, 2.33. And then the B is, what, 0.8 something? 802 to the X, and we did it. All right. Those are the most painful kind. Those are the ones that make you feel like you earned a 3 or an A. Will it give you the what? No, you have to memorize Ly equals L over 1 plus AB to the X. Nice part is this is just the, what do you call that one? The exponential one buried inside. All right, you're getting close to done. Two bases are equal. Well, these two bases are not. But you agree I could take the 4 out and put in a 2 squared? 2 squared to the x equals 2 to the 6th. Once that happens, these have to be the same. 2x has to equal 6. So what's x got to be? Yep. If my life depended on it, I'd put in a 3 there and make sure that 4 to the 3rd is actually equal to 2 to the 6th. And it is. All right. Yeah, we don't need to do more of those. Yep. Any equation you can graph and find out the answer. And type that exact thing in. 4 to the x equals 2 to the 6th. See where they cross, and it'll be 3. I'm reminding you of this because it's coming up. You're going to use it at some point in some bigger problem. Okay? The problems are not this simple. This is like R2, even easier than R2 level kind of stuff. But you're going to need to know this base stuff for later. I'm just kind of getting you ready for later. Okay, this kind, I hope you remember the shortcut way. The long cut is like this. 20 milligrams at the beginning, so 0, 20, and it has a half-life of 50 days, means 50 days, comma, half of 20 would be 10. Do you see how I got my 2 points? Now I've got 2 points. I can stick them in, do it the normal way. But there's a really fast way to do this. Remember this? Y equals starting value, 20, times. Is it growing or shrinking? So I put half in there. And 50 days, x over 50. Do you remember that? That's the answer you'd get. If you did it the long way, you'd still get that answer. You might have a decimal that would mean the same thing, but in other words, this might be 20 times 1.047 to the x, but they would give you the same exact answer. So this shortcut way is totally okay, and you know, let's say 98% of the students use the shortcut way. But if kids forget the shortcut way, this is a backup that'll work. You got your starting value there, plug it in. You got an x and a y, you plug them in here and here, and you solve, and it ends up taking you a while, but you can do it that way. All right, would you please, if you understood that, answer my chipmunk question. I will after people are done with this one. First I'm going to do this one. If you understand this, you know you just start with the starting, and then you just figure out what's happening, and you put it in here. Doubling, 2. Every 2 weeks. X over, raise your hand if you had that one right. Good. You need that pattern. It's going to come up, and it's easy. Answers are quick. And you can do it with 2 points if you want to. Starting value would be 0 goes with 350. And then the other one is after 2 weeks, 14 days, always go to days, comma, 700 if you doubled. And you could use those 2 points, and you could do it that way. Okay, questions? You asked about the last question, but I'll get to that after this question. Any more questions about this one? Why do you always go to dates? Well, because these problems are exponential, and exponential is always time versus growth of whatever it is. It might be the weight of a chipmunk or the number of atoms that are, still have carbon in them or whatever it is, but it's an amount here that's, it might be height, it might be number of birds, but it's almost always versus time. That's what exponentials do. You could do weeks, but okay, why do we always do days? Is that what your question was? Oh, I thought you meant why do we always have time in these equations? Days versus weeks. I don't have an answer for you on that. It may be something I'm glossing over in the directions of the problem, which might say something like give your answer in days. Okay, if it said, is that it? Okay. Okay, so if the question said give your answer in weeks, then you'd put every 2 weeks, you just put a 2 here. Yes. Yes. I'm sure you can, but may I would be the question. All right, almost done here, so give me 10 seconds to wrap this up. All right, so this kind of problem is the only other one left. Do you get that that's on the inside? Apparently you don't want to watch this last part. Go ahead, hurry, make it fast. Do you get that's on the inside? So I could take this whole thing and move it to the left or right? Left. And then what's that 3 in the front of it? Shrink. Does it matter what order I do it in? Yes, it does. You do it in the wrong order, you get it wrong. So, what comes first? Well, normally the multiply comes first. When I have the arrow on there, that goes first. So, you should instead do this first, because the normal order of operations says multiply first. So I do that plus 3, which means left 3, and then, so first, and then second, I would do my 3 times narrower, or some people like to say a stretch factor of 1/3, or as long as you get across the point that it's getting smaller. Remember that things on the inside do the opposite of what you expect. It's not 3 times wider. All right, to see if you really get that, last thing I want you to try before we're done. Just tell me, what would that one do? And tell me in the right order. First you do this, and then you do that. And then you do that. All right, first thought, I'm going to rewrite this as negative 4x plus 3, because I'm a rebel like that. Then I'm going to say multiplies normally come first, so I'm going to do that first. So you should have said 3, and that 3 is positive. That negative, that's on the 4. That 3 is positive, so that's 3 to the left. How many of you guys started with left 3? Good. Then you have a chance of being right. Next step. Next step is that negative 4x. It's actually 2 things. The negative is a flip, and the 4 makes it narrower. My classes, the way I explained it is, it's like gymnastics. Normally, you always want to stretch before you flip, right? Because it doesn't make sense to flip first and then stretch out. Stretch before you flip. Since we're on the inside, we don't stretch before we flip. We flip before we stretch. And the flip is which way flip? It's an inside one, which is a left-right, which is over the y. And the stretch one is a left-right thing, so it's a left-right stretch, but it's actually a 4, which means it doesn't actually stretch, it's a shrink. So it's 1/4 as wide. Who had it exactly right and in the right order? Okay, that's about 3/4 of the class. So you can see that's not it may look like a super easy question, but it's easy to get it wrong, because you do it in the wrong order, you get it wrong. All right, we'll do another practice like that tomorrow. So there's our practice for today. Your homework is right here. It's the last book assignment, then we got a worksheet tomorrow. This is page 296. Problems 23 through 29. And, you know, in my opinion, that's a little too long. So let's do 23 through 24, and then 29. Let's skip a bunch of those. And then 33, 39, 40, 45, and 46. I think that ends up being 8 questions, okay? That's doable. So get it done. And it'll be great practice for the test, which is coming in 2 days.